Hello everyone. Welcome to session 3 of this training course. Today, we're going to dive into the additional hardware that could be operating alongside the MOVIDRIVE to expand its capability. We'll discuss some encoder theory and discuss the purpose of the different encoder types. Then this session will wrap up by introducing our software packages and showing you how to download and install it so we can use it later on in this course. The MOVIDRIVE is modular, and there are a lot of accessories that can be added at the time of order or later on if the application requires it. We'll start with the power-related accessories that give the MOVIDRIVE more flexibility in dealing with challenges and applications that can't be overcome just by changing a parameter. One of the challenges that has to be dealt with is managing the regenerative energy that occurs when controlling electric motors. Regeneration happens when the rotor shaft of the motor is mechanically rotated faster than the speed the inverter is sending. This is common in hoists when it's lowering because of gravity and in applications that have a lot of mass that is being slowed down by the inverter. In these scenarios, the motor changes from being a consumer of energy to being a producer of energy. The energy has to flow somewhere, so it goes backwards towards the inverter and starts charging the DC link above its steady level at 700 volts. The DC link capacitors have limits around 1000 volts, so if the charge level reaches this point, the inverter has to have another place to continue sending the excess energy. A common way to deal with the excess energy is to send it to a brake resistor that dissipates it as heat. These are just coils of wire and metal bars that have a specific resistance value. These will vary in size depending on the kilowatt rating of the inverter and how much regenerative energy the application produces. This is the easiest method to deal with the excess energy, and most inverters will have one connected to keep the inverter from faulting, even if it's not regularly used. Even though the brake resistor is the easiest and most common way to handle excess energy, it is fairly wasteful. So there's an alternative where we can send the excess energy over to a regenerative power supply we call the MDR60A. This is essentially a bank of capacitors that can absorb a lot of energy and return it to the power supply line or temporarily store it for the inverter to use in another travel cycle. These connect to the inverter's DC link connection, and in some scenarios, the inverter doesn't even need a direct connection to the AC supply because the regenerative supply is making that connection already. These have a range of kilowatt ratings they can support, so if the regenerative power supply is sized correctly, it is possible to have multiple inverters connected to a single one. It can save a considerable amount of energy over time since we're recapturing energy that the MOVIDRIVE has had to put into the application. The MDR is an investment, so you will need to determine how much energy is being wasted by a resistor and what the return on the investment will be over time of reclaiming some of that energy. There are several sizes of these, but the smallest one is rated for a 15 kilowatt load, so the MDR will have more benefits for larger power applications than the smaller ones. As a side note, the project planning of which power size you pick and how it will connect to the multiple inverters has to be correct. I recommend reaching out to your local SEW engineering department to help you with the selection process if you want to use this. Sometimes power is not always steady, or it could have a good bit of noise on the line because of all the machinery that's in a manufacturing plant. An inverter can generate a lot of electrical interference because it has to convert AC to DC and back to AC with rectifiers and transistors. This noise sometimes can radiate enough that it can cause issues with sensitive devices like PLCs and encoders. One of the components that can be added to help with this is a line filter. This device connects between the inverter and the supply power, and it helps keep noise from getting back onto the supply line, and it can clean up existing noise that may already be there from coming into the inverter. A line choke is used for a different purpose than the line filter. The choke has inductive behavior, so it impedes current flow, which causes a voltage drop across it. What this means is it can reduce the amplitude of inrush current when switching on an inverter. Also, when other line contactors in the cabinet switch, or if lightning indirectly strikes the building, this can cause high energy overvoltage pulses at the inverter that peak past its rating. A line choke can help smooth these high voltage pulses from causing damage to the inverter. So far, we've been talking about the devices upstream of the inverter, but sometimes we need to clean up the output of the inverter. The output choke is a cost-effective way to dampen the high-frequency leakage currents that come from the motor cable. It works by wrapping the 3 individual motor phases that come out of the inverter in a loop around this coil before it exits the electrical cabinet. This is helpful in cases where unshielded motor cable was used and there may be an encoder cable routed near the motor cable that could see some electrical interference. The output filter is helpful in applications with long motor cable runs. Some applications with long motor cables or shielded cable can cause recharge currents high enough to damage the inverter's transistors. Also, voltages can peak inside the motor winding because of the long motor cable, which stresses the motor's insulation. The output filter is designed to reduce these peaks seen in the transistors and at the motor windings. Because of how the output filter works, it is not a good fit for some applications. This is especially the case with hoists and with applications that need flying restart. The output filter can reduce the output torque from the inverter, which would cause the motor to drop the load or not be able to restart properly, which could be dangerous. In non-hoist applications, the inverter's size and filter has to be selected correctly. In some instances, the inverter size has to be intentionally increased to account for how the output filter could reduce the available torque. Let's switch from cleaning the power to discussing the Fieldbuses the MOVIDRIVE can support. Fieldbuses are industrial networks, and they are becoming more important as new machines are being brought into manufacturing. These industrial networks are necessary as there are becoming more devices that are decentralized and located throughout the plant. Now, this image here is an exaggeration because you typically wouldn't use this many different Fieldbus protocols in one plant. They may have some older machines using Profibus and new machines using Profinet, but not all of these protocols at once. What this image illustrates is how different types of devices could potentially be connected all the way up to a high-level corporate network for the plant. To help make sense of all the types of Fieldbuses that are out there, we can classify them into 2 categories. The first category is classic Fieldbuses that were developed starting in the 80s. These were Profibus, DeviceNet, RS-485, CAN bus, Interbus, AS interface, etc. The newest types of Fieldbuses are based on Ethernet, which would be EtherCAT, Profinet, and Ethernet IP. These have been getting more popular over the past 15 years. Our MOVIDRIVE can support most of the major Fieldbus standards. Here are some of the Fieldbuses that we can support in the classic category. These option cards can be installed in the MOVIDRIVE expansion bay to give it direct access on that type of network. So we have CAN Open, DeviceNet, which is kind of geared towards Allen Bradley, Interbus, Interbus Fiber Optic, and Profibus, which is geared towards Siemens. Here are the newer Fieldbus protocols based on Ethernet. The MOVIDRIVE can support Profinet, Ethernet IP, and Modbus TCP within the same option card, and EtherCAT. EtherCAT is a high-speed, real-time Ethernet that is gaining popularity in robotic and CNC applications that need high-speed performance with precision accuracy. Here are some earlier versions of the Ethernet-based Fieldbus cards. These are now discontinued, but you may see these out there if you have a MOVIDRIVE that was an early adopter of the Ethernet Fieldbus. All of our new option cards contain an integrated Ethernet switch, so you can daisy chain the network in and out of the MOVIDRIVE without having to go back to the main switch for each device connection. Now let's talk about some feedback options the MOVIDRIVE has so it can do closed loop control. We'll start with encoders. The word encoders is sometimes used as a broad term to indicate a position feedback device, but there are many different versions of encoders, and how they operate can vary widely. The purpose of encoders is to provide the data needed for speed control or a motor's position. The encoders can be high or low resolution. This means for every rotation of the motor shaft, it can be low resolution and getting less than 24 pulses per rotation, or it can be high resolution and getting 2048 pulses per rotation. This image in the middle here is the low resolution version, and it works by counting magnetic flags that are made into the fan on the motor. These are sometimes desired because it doesn't add any length to the back of the motor, and for applications that need simple positioning, this is a cost-effective solution. There are two categories of encoders out there that we offer for our motors. We can summarize all of the encoders we offer into either incremental or absolute, which we'll get into more detail next. Incremental encoders are very popular because of their cost, and they offer really good speed control and positioning accuracy. Most of them are sensed optically or magnetically. This version shown here works on an optical design. This disc has cutouts in it that let light pass through in a specific pattern. A phototransistor sensor will be on the other side of the disc to read the pattern of the light passing through. That sensor will then output electrical pulses that match the pattern it sees. With these pulses, the inverter can determine the speed the motor shaft is rotating at, and it can determine a direction of rotation based on the order of the pulses coming in. An incremental encoder is specified in how many increments or pulses it can output per rotation. Some of our common incremental encoders output 1024 pulses per revolution, which is really good resolution for numerous applications. One thing about incremental encoders that makes them not the best fit for all applications is that they have to be referenced before it can be used for positioning. This means the machine has to be brought into a home location and the encoder counts are set to 0, so it knows where to start from. Incremental encoders can't store its position, so anytime power is switched off, or if a fault is reset on the inverter, the machine has to be brought back to the home position to reteach the encoder where the 0 location is. Absolute encoders really shine when used in applications that need precise positioning. A lot of these work by being sensed optically. If you look at this code disk, you can see that this is a lot more complex than the type used in incremental encoders. Because of this unique pattern of the optical disk, the light that passes through can be interpreted as a binary number that refers to a unique position. As the disk rotates, a specific number is output that will count up or down depending on the direction of rotation. The advantage an absolute encoder has is that it only needs to be referenced once. Even if the power is switched off to the device, as soon as it comes back on, the light pattern will output a unique number so it knows where it's at. The only time the encoder would need to be referenced is when the inverter or encoder is swapped with a different one, or if the motor was taken off the equipment for maintenance and put back on. There are multi-turn encoders that can keep track of multiple rotations that would give 16 million unique positions, which gives the ability for longer travel distances. Absolute encoders don't have to be rotary. They can be linear too. Here's an example of a barcode scanner that we use on our paint assembly line. These are stickers that can be placed on your machine and a reader will output the specific location. A lot of the absolute encoders we use on our motors will have an incremental channel that is used for speed control, while the absolute channel is used for positioning. Lastly, another common absolute encoder is a laser that measures the real distance based on how long it takes a light beam to hit a reflector and return to the sensor. These are really common in hoists and linear positioning applications and can have accuracies to tenth of a millimeter. I will mention that one downside to absolute encoders is how long you can travel in one direction. Absolute encoders are better suited to applications that travel forward and reverse. But in turntable applications or conveyors that always travel one direction, it's possible the absolute encoder could overrun the amount of numbers it can output because the code disk can only count so high. In those instances where overrun of the numbers is possible, it's best to use an incremental encoder instead of an absolute. The next type of feedback device is called a resolver. We only sell these with our permanent magnet servo motors, and they are in the incremental category. These are the default selection unless you wanted an absolute encoder for the servo motor. Resolvers are very durable and can handle the heat generated inside a servo motor. The signal that comes out of these are different than an encoder. Resolvers are supplied with low voltage AC, around 7 volts, so that results in an analog signal. This signal has to be processed in the resolver option card that can be installed in a MOVIDRIVE, so this is why it doesn't have any circuit boards on it. These behave somewhat like a single turn absolute encoder because it can't store how many rotations it has when around, but it does know what degree of rotation it's currently at. Since the resolver operates on AC voltage, we can determine the motor shaft position from 0 to 360 degrees based on the sinusoidal signal that comes out of the resolver. If you look at this picture, it resembles how an AC motor is built. You have a stator and a rotor. One of the things that is crucial with getting the resolver to work properly is verifying during assembly that the resolver stator to the rotor is oriented 90 degrees apart. This is why we don't recommend taking apart the servo motor in the field. If the parts aren't aligned correctly, the servo motor won't work and will cause the MOVIDRIVE to fault. There are procedures with using an oscilloscope or our MOVITool software to align these in the field, but you would need the assistance of your local SCW engineering group to talk you through it so it's done correctly. Without an option card installed, the MOVIDRIVE can't read an encoder signal. It will need the proper interface that is compatible with the encoder. There are numerous different standards out there that an encoder can be based on, and these are the ones that we support. Several of these standards can be available on a single option card, so there is flexibility. You would just need to have the parameter selection correct, telling the card what type of standard it needs to be accounting for. The one that is different is the resolver option card. It is specific to only resolvers because it has to supply AC voltage out instead of DC. So that is a dedicated card that would need to change if you previously had an encoder option card and were switching over to a servo motor with a resolver. SCW supports almost all of the common standards. There are some standards out there you may have heard of, such as push-pull, open collector, and differential line driver. These standards are more common in third-party encoders. If you have any third-party encoders with this type of signal, I recommend reaching out to your local engineering department with your motor and encoder data sheets to determine if we have any option cards that can support that type of signal. For example, a differential line driver encoder may be compatible with our TTL option card, but we have to evaluate each one on a case-by-case basis and determine if that third-party encoder is compatible with our option card. Here are the option cards that we offer, and I want to give you some general truths about them to make them easier to understand. The majority of our encoder cards will have two connectors on them. The bottom connector, labeled X15, is always the motor encoder. This is standard across any of our inverters that support encoder feedback. It can only be used for the encoder that's directly on the back of the motor shaft. X15 can be used for speed control and for positioning at the same time. The top connector that will be labeled X14 or X62, depending on the model you have, is for any external encoder that's not the motor encoder. This is commonly used when machines have secondary encoders, such as a rope encoder or a barcode reader, to determine its physical location. The interfaces that are supported will vary card to card, and there are a few different selections to choose from. Some of our cards can provide encoder simulation output from X14. This changes the X14 input to being an output, and it can duplicate the motor encoder signal and send it to other devices, such as another MOVIDRIVE. This is very common when multiple MOVIDRIVEs are synced together. For example, a common way to connect a master and a slave MOVIDRIVE together is to take the master's output signal from X14 and then connect it to the input X14 on the slave for it to follow. Lastly, one thing that is important to remember is that any encoder or resolver connected to X15 will be scaled up or down to always equal 4096 pulses per revolution. For example, if the actual resolution of the motor encoder is 1024 pulses per revolution, the MOVIDRIVE is going to upscale that to 4096, and if we looked in the parameters, this is what we would see per rotation. This is helpful to know during troubleshooting to determine if the encoder or motor is wired properly. We know that for each rotation of the motor shaft, we should see 4096 pulses counting up or down depending on the direction of rotation. Here are our encoder cards. Our most common encoder card is the DEH11B. It supports the most common motor encoder standards for X15 and X14. It can also be used for encoder simulation. The next option is the DEU21B. It adds support for a lot more standards on both the X15 and X14 connections. The next encoder option is different than the rest because it has to be used in the tall expansion slot of the MOVIDRIVE, and it adds some additional binary inputs and outputs if you needed more I/O. You'll notice the encoder port is named X62, and this is because it only supports SSI encoders. This stands for Synchronous Serial Interface. This is used for absolute encoders and is a very common protocol for laser distance encoders. The next option is the DEH21B. This encoder mixes the capability of the standard DEH11B and combines it with the DIP11B. This is why you'll see the top port is labeled X62 instead of X14 because it only supports SSI encoders. Something unique to both the DIP11B and the DEH21B is that they require their own 24-volt input to operate. Now you may be wondering if you can just use some jumpers from the MOVIDRIVE terminals over to this card to power it, and the answer to that is no, you shouldn't do that. The MOVIDRIVE can only support 400 milliamps max across this entire 24-volt internal supply. So these encoder cards can draw more current than that, so an external 24-volt supply must be fed to these cards so it doesn't pull down the internal supply of the MOVIDRIVE. Lastly is this DER11B option. You'll notice that on X15 it only supports the resolver type because it can only output AC voltage. However, on its X14 port, it can support some of the common standards and be used for encoder simulation. So there are 5 different encoder cards you can choose from. The MOVIDRIVE can expand its onboard inputs and outputs with option cards if the standard quantity isn't enough. I already mentioned the DIP11B, but what if you don't need that port for an absolute encoder? Then there's an option called the DIO11B that removes the encoder port and adds one more analog input and two analog outputs. This card is flexible because it can be installed where the Fieldbus usually goes, or it can be installed in the tall expansion bay and will have a blank cover above it to fill the rest of the slot. This is how our demo units are set up. We have a size 1 MOVIDRIVE with an encoder card, an Ethernet IP Fieldbus, and this DIO11B option in the tall expansion bay. Our last I/O expansion card is unique. It is called the DRS11B. The card's main purpose is to be a master-slave synchronization card, and it has some digital input and output capability as well. You may remember from the previous training session that I said an IPOS program or an application module can be used for master-slave operation. Well, the DRS11B is a way of doing synchronization without an IPOS program because it is a hardware solution instead of a software solution. This card would only be installed in the slave MOVIDRIVE, and it can read external encoders from multiple sources and can also send encoder simulation out if there are more than one MOVIDRIVE slave in the system. If you remember from the last training session, I said to be careful working with the yellow cards because they are for functional safety. Here's a look at some of the option cards that can install directly in the MOVIDRIVE. These first 4 cards are for safe Fieldbus communication to an external safety controller. These other tall cards on the right are more complex and could have safety programs loaded to them, which would require you to make sure none of the wiring changes and that if you have to replace the MOVIDRIVE, that it is moved to the replacement. We won't be discussing these in this course, but I just wanted you to get a visual of what they look like. If you're located in the United States and need support with our yellow option cards, you can call our corporate electronics office located in South Carolina and ask for the functional safety department. They have the certifications needed to assist you with any of our functional safety devices. Something else that we can expand our MOVIDRIVE's capability are what we call a controller, which are small PLCs. The name of our controllers are MOVI-PLC. These can be directly installed in the MOVIDRIVE or can be installed in these external housings that can be snapped to a DIN rail or be screwed to the back of the electrical cabinet. The MOVI-PLC is based on the IEC programming language, which is called PLC Open. This is a common language used in many PLC manufacturers, and it supports common styles of programming. These are sold in different technology levels depending on how many different axes you need to control with it. And it supports different Fieldbus protocols such as DeviceNet, Profibus, Profinet, Ethernet, and Modbus TCP. These extend the capability of the MOVIDRIVE to be used in multi-axis applications such as robots, camming, and storage retrieval systems. This training course doesn't go in depth with working with these because of how configurable and advanced their nature can be, so I just want you to know that they are commonly used alongside a MOVIDRIVE or MOVITRAC, and if you see this in your electrical cabinet, that means it's likely being used to control multiple inverters, and it likely has its own program on it. Here are the different models. The first one is this 11B series that is now discontinued because we decided it was too underpowered for a lot of applications. The only way to access the program in this version is to use the serial port at the bottom of the card with our USB 11A cable that usually connects to the MOVIDRIVE. The other models all have a dedicated engineering port that can be connected to a PC with a standard Ethernet cable. The difference between the 21B version and the 41B version is the amount of axes it can support. The 21B cards can support a max of 8 interpolated with 8 non-interpolated axes, bringing the total to 16. The 41B cards can support a max of 16 interpolated with 16 non-interpolated axes, bringing the total to 32. Now, these are the maximums the card could support, but this can be reduced if there are axes that have complex process data traffic. Now let's talk about our software, which is a crucial component to really activating the full features of the MOVIDRIVE and the option cards that can be installed. I've mentioned it in the previous training session, but all of the software tools for each of our inverters are available for free. The software that you can download off of our website is the exact same version that our employees use. So you have the opportunity to do almost everything we can, especially when it comes to inverter setup and troubleshooting. This training course will show you how to use the software to your advantage. The software package that we will be using in this training is called MOVI Motion Studio. If you haven't installed this package or know where to find it, I will show you how to do that coming up shortly. This is the tool you would need to interface with most of our devices. The exceptions would be for the functional safety cards and some of our older inverters that have been discontinued because those use a different software package. The Motion Studio software isn't just one tool, but it's many tools in one. You can modify parameters, back them up, restore them, commission the motors, write PLC or IPOS code, configure application modules, and conduct scope recordings of the inverter for troubleshooting. With the newest generation of product, we've brought on an entire new software tool called MOVI-Suite. This is also a multifunction tool, but is specific to anything Generation C that is currently being released or that is still in development. This software is also free and can be downloaded from our website. If you would like to see how to install Motion Studio, that is coming up right now. If you haven't downloaded our software that you will need for this training course, then let me show you how to do that. If you already have this software installed and want to skip past this, then you can jump ahead to the time shown here to get to the next portion of this training session. The first thing you'll need to do is open up your web browser and go to our USA homepage, that is secweurodrive.com, all is one word. Once you're on the homepage, you'll want to come down to the left-hand tabs and select Documentation, Software, and CAD. Once you're in this screen, you will click into this blank search bar and type in Motion Studio, all is one word, and click Start Search. Once the search filter has finished, you will see a lot of results. You want to come down to this second result that says MOVI Motion Studio Complete Full Version. There will be a floppy disk icon off to the right-hand side, and it will say how large the file is. You'll want to click on this icon. You'll be presented with a privacy notice that you will need to accept to download the software. Then, depending on your browser, it may ask where you want to save the file. You want to make sure that you save it and do not open it automatically. So I'm going to choose Save As. And then I'm going to put it into the Downloads folder because I know that's an easy place to get to. And then I will press Save. Depending on your network speed, it can take quite a while to download 2 gigabytes, so you'll want to wait for the download to finish, and then we'll come back after the download has finished. The download is now complete, and you may notice that it is a zipped folder, so you'll need to right-click on the zip folder and then choose Extract. The extraction may take some time, so you'll want to wait for that to finish. All right, the extraction finished, so we can come into the now extracted folder. And then you'll come into this Motion Studio folder. And then what you'll want to see down here is this SEW setup.exe. You will need administrator privileges to run this setup, but you will double click on it. If you have administrative privileges, then the first screen you will see is to choose your language. So you will want to choose your language and then click Next. The next thing that's very important is to choose Complete with Control Technology. This will give you all of the sub-tools inside of Motion Studio that you will need to do diagnostics and to potentially set up any application modules or any IPOS programs. Then click Next. The software will default to a program location. You can leave it in the default location if it's okay with you, and then click Next. The software is telling you what it's going to install. If you care to see this, you can scroll through the list and see all the tools that will be installed. And then click Next. If you agree to the licensing agreement, then you can click on I agree. And then click Install. The install will take quite a while, so let it finish until it's complete. And that's how you install Motion Studio. All right, we have reached the end of our third session. In this session, we went in depth with the external hardware the MOVIDRIVE could be operating with, such as power filters, encoder cards, I/O expansion cards, and Fieldbuses. We discussed some encoder theory and how the MOVIDRIVE can support different encoder signal types. We ended this session by discussing the software that we'll be using later on and demonstrated how to download and install it. In the next session, we will go in depth with the different model types of the motors we offer and how to understand what's printed on the nameplate. Thank you for your attention. Take care and have a good day.